In previous podcasts, we talked about how if a toxin is water soluble, it gets urinated out. How it's the fat soluble toxins that cause the real problems. They get into the lipid membranes of the body, and they're very hard to get rid of. And what detoxification is really about is finding the right kind of soaps, as it were, that can make fat soluble toxins water soluble so we can urinate them out. We talked about heavy metals and toxic chemicals. I call these first generation toxins. In this podcast, I'm going to talk about another class of toxins I call second generation toxins. These are toxins that are created inside the body by the first generation toxins. I'm going to talk about what they are, what problems they cause, and how we can get rid of them. First generation toxins include toxic metals like mercury, lead, and oxidized iron, as well as chemicals like the pesticide glyphosate. What makes these toxins so damaging is their reactivity with our fats and proteins. If they were less reactive, they wouldn't cause that much damage. And if they were more reactive, they would bind irreversibly with our tissue and then stop reacting. Instead, these are in the middle. They are reactive enough to cause a lot of damage, but not so much as to get permanently bound to the fats and proteins they're reacting with. What they are is catalytic. In other words, they don't get used up while they're doing their damage. This means they can continue to do their damage for as long as they're in the body, and that can be for a long time, as the body has a very limited capacity to remove them. Now let's talk about second generation toxins. Some of the oxidized and rancid fats and damaged proteins that the first generation toxins create can be dealt with by the body. They can be recycled by our lysosomes, the small acidic organelles in our cells, whose job it is to recycle old and damaged fats and proteins. But some of these damaged fats and proteins can't be dealt with by the body. The lysosomes can't recycle them. I call these second generation toxins. And like the first generation toxins that created them, they also are catalytic in nature. They will also keep causing problems as long as they're there. And these problems include heart disease, neurological issues, and senility. There are three classes of these second generation toxins I want to talk about now. They are toxic fats, toxic waxes, and toxic proteins. Let's start first with the toxic fats. The body is a collection of trillions of cells, and every cell has a membrane around it. And with the exception of red blood cells, every cell also has hundreds or thousands of smaller cells inside it called organelles, and each of these organelles also has a membrane. Membranes are more than just the skin of the cells and organelles. Membranes decide what compounds go in and out of the cell and the organelles. This controls how the cell behaves. It controls what the DNA does and what kind of proteins and fats are produced. Membranes are truly the brains of the cell, and damaging membranes is the equivalent of a cellular lobotomy. Membranes are made up of about 50-50 fats and proteins depending on the membrane. So let's start with the fats. Over time, these fats oxidize and need to be replaced. It's the job of the lysosomes, one of these organelles inside the cells, to recycle oxidized fats. However, over time, the lysosomes get damaged by toxic metals and overwhelmed with the sheer volume of oxidized fats they have to deal with, and thus these oxidized fats begin to accumulate. In the case of oxidized cholesterol, it forms crystals, and once these crystals reach a certain size, they can no longer be dealt with by the cell's lysosome. It would be like trying to eat an elephant with just one bite. So the cell then sends out emergency signals to the macrophages to come and help. Macrophages are mobile lysosomes. In addition to fighting infections, they also travel through the body and help recycle and digest toxins. But the macrophages are also no match for large cholesterol crystals, and they also die trying to digest them. The dying macrophages then send out a signal for other macrophages to come and help, but they also die, and the process continues. It's a blind spot in our metabolism and our biology that we can't deal with these large cholesterol crystals, and the reaction keeps going on out of control. This is how plaque forms and why it nearly always continues to grow. Plaque is literally made up of the accumulation of oxidized fats and cholesterol crystals and the bodies of dead macrophages that tried to eat them, which become what are known as foam cells. So cholesterol crystals represent one of these second-generation toxic fats. Another toxin that fats can turn into are toxic waxes. Waxes are similar to fats, but the chemistry is slightly different. They happen to be alcohol-based rather than glycerol-based. When we're born, we are covered head to toe in a healthy wax called the vernix caseosa. It's made up of a substance called ceramides. The issue is that saturated fats, the stearic, palmic, lignocerics, they can combine with metals to form toxic waxes, also known as metal soaps. They can combine with metals like mercury, lead, barium, nickel, iron, cadmium. They can also combine with calcium. This is one of the ways that toxic metals can lodge in the fatty tissue indefinitely. As we get older, the healthy ceramide waxes that we are born with get replaced by toxic metal soap waxes. One example of such a toxic wax is lipofuscin, or age spots. If you see age spots on your skin, that's a clear indication that you might be dealing with toxic waxes in your metabolism. Finally, there are toxic proteins. Proteins are the long chains of amino acids that the DNA instructs the ribosomes, another cellular organelle, to make. These long chains of proteins are then folded in the endoplasmic reticulum to form the proteins that we use. It's the shape of the protein that gives it its ability to do its job, whether that's insulin or antibodies or growth hormones. Think of proteins as long balloons and the endoplasmic reticulum as the friendly uncle that twists and folds the balloons into things like a hat or a dog for a kid. The issue is that first-generational toxins, especially toxic metals, can cause these proteins to misfold in the endoplasmic reticulum. That is, take the wrong shape. Now, there is a quality control system in the endoplasmic reticulum that sends these misfolded proteins to be repaired if possible or recycled in the lysosome if not repairable. Alas, with age and toxicity, the number of misfolded proteins increases past the endoplasmic reticulum's quality control systems to handle. The cell is thus given a difficult choice: decrease protein production leading to a deficiency state, or maintain protein production but overwhelm the quality control systems of the endoplasmic reticulum and the lysosomes, and end up with an ever-increasing number of misfolded proteins in cytoplasm. Why is this a problem? Two reasons. One, most normally folded proteins have their fat-soluble parts in the center and their water-soluble parts on the outside. This makes them water-soluble so they can be moved around to where they're needed. Misfolded proteins, on the other hand, can have some of their fat-soluble parts stick out from the center. This makes the proteins fat-soluble, and as a result, they can stick in the membranes and be hard to get rid of. It's not that they're toxic on their own necessarily, but the sheer mass of them can gum up the cellular machinery. The other reason misfolded proteins are a problem is that some of them can be further converted into something called prions. You've probably heard of prions in the context of mad cow disease. Yes, that is one kind of prion, but there are many more. There are, in fact, more than 50 diseases we now know are caused by prions. These include Alzheimer's, Parkinson's, MS, ALS, cystic fibrosis, cataracts, type 2 diabetes, senility, and the list goes on. Like toxic fats and waxes, prions are extremely stable and virtually impossible for the body to get rid of. They resist digestion by proteases in the lysosome. What's worse is that once you get a single prion, if it bumps into another protein, now you have 2 prions, then 4, then 8. You can see that this exponential growth is going to be trouble. While we might never be exposed to prions in our food supply, we make them internally. Certain chemical toxins like organophosphate pesticides can take a misfolded protein and turn it into a prion. This is one way that first and second generation toxins can interact. Metals get into the cells, the proteins get misfolded, these misfolded proteins bump into a pesticide, and boom, you've got a prion. From there, the replication rate of the prions goes exponential. Also, prions are transmissible. This explains why the spouses of people with Alzheimer's are 600% more likely to get Alzheimer's themselves. For this reason, if one person has any protein folding disorder, it would be wise for their spouse to also consider the protocol I'm going to share at the end of this talk. There is also a signature on the spike protein that is eerily similar to that of prions. So there may be a prion-like aspect to the spike protein as well. As a side note, I believe it is the accumulation of these toxic fats, waxes, and proteins and the damage they do that is the main cause of aging. We can heal a cut in our skin. Why can't we heal aging? Because until now, we didn't know how to get rid of these second-generation toxins. What's the answer? Sugar donuts. And by sugar donuts, I mean, of course, cyclodextrins. Cyclodextrins are microscopic sugar donuts, that is, tiny rings of sugar, 10,000 times smaller than a red blood cell. While there are many cyclodextrins, there are two in particular that have tremendous promise for improving our health, and these are the alpha and beta hydroxypropyl cyclodextrins. Alpha cyclodextrin is a 6-sugar ring and beta cyclodextrin is a 7-sugar ring. What this means is the hole in the middle of the alpha cyclodextrin is a little smaller than the hole in the middle of the beta cyclodextrin. These holes, these rings, can trap second-generation toxins like toxic fats, waxes, and prions. Since the outside of a cyclodextrin is water-soluble, the body can then simply urinate these toxins out. Okay, let's talk about these two in a little more detail. Alpha cyclodextrins can trap and remove trans fatty acids and oxidized saturated fats and phospholipids and toxic waxes. It also triggers the conversion of those same toxic waxes back into ceramides, the waxy substances found in youthful skin and membranes. Alpha cyclodextrin also traps prions and makes them water-soluble as well. Beta cyclodextrins are best at removing lipoproteins and polyunsaturated fats, as well as the aromatic toxins and heterocyclic toxins that are made by cooking meat at a high temperature. Beta cyclodextrins remove cholesterol crystals by increasing cholesterol solubility by 150,000 times. In fact, it's 50 times more efficient at removing 7-ketocholesterol, the main toxic form of cholesterol, than apolipoprotein A1, the good lipoprotein that we want. And this is one of the reasons why beta cyclodextrin has been shown to help decrease arterial plaque size. Beta cyclodextrin also works in the liver and has been shown to decrease cholesterol crystals in the Kupffer cells, which is an issue with people that have non-alcoholic fatty liver disease. Beta cyclodextrin also reduces lipofuscin, which, as I mentioned before, is one of the signs of aging, and that toxic waxes are building up. While I've focused on heart and brain health, cyclodextrins can do much more. Cyclodextrins can encapsulate and render non-toxic 20 different mercury compounds, break down immune complexes so our allergic reactions don't become chronic, remove allergens, remove carcinogens, remove aflatoxins, lower tumor necrosis factor alpha and interleukin-6, as well as other inflammatory markers, improve liver function, increase bile output, and here's an interesting one, reactivate paralyzed white blood cells. I used to do live cell analysis with a microscope 30 years ago, and one of the things I would see is that some people had white blood cells, the macrophages, the neutrophils, that would move quickly and gracefully through the blood looking for toxins and infections. Other people had neutrophils that were stunned, paralyzed. They couldn't move at all. And some people had neutrophils that were just exploded, dead, and blew into pieces. And I was wondering what makes it so that some neutrophils seem paralyzed. And now what I understand is these are the neutrophils that have eaten so many toxic fats and waxes and crystals and folded proteins that they can't move anymore and they can't digest them either. And they are basically immobile and eventually they explode and die. So the ability to recover the neutrophils and the macrophages is spectacular. It means that the immune system can get an excellent upgrade to its capacity. Cyclodextrins also can shrink enlarged lysosomes. Enlarged lysosomes are a hallmark sign that a cell is stuffed to the gill with toxic waxes, fats, proteins, and metals. It's not just the white blood cells that can get stuffed and paralyzed, the lysosomes too. Usually a person has to do a water fast to even start shrinking enlarged lysosomes, and even then it can only go so far, since the toxic fats, waxes, and proteins, they're often indigestible, even in a fasting state, and they just won't budge. By interacting with these toxic fats, waxes, and proteins and making them water soluble, cyclodextrins can shrink lysosomes in ways that fasting can never accomplish. And that's coming from someone who's done a lot of long water fasts and has a tremendous respect for fasts and their healing potential. Shrinking enlarged lysosomes is a fundamental requirement for those not only looking to stay healthy, but living as long a life as they can in that healthy state. And until now, it's something we've had no idea how to accomplish. When I first started researching cyclodextrins and saw how powerful they were at dealing with these seemingly unsolvable problems of aging, I started experimenting with how to take them. Now, they're usually done intravenously, but after a few months of research, I found a way to make them orally absorbable. So if you are curious to see what cyclodextrins might be able to do for you, I have a product now called Albodextrin, which is short for alpha and beta cyclodextrins, and it's available for you to experiment with. Now there's a caveat. You should not do cyclodextrins if you are low on cholesterol or have cholesterol lowering drugs as part of your protocol. It is possible to have cholesterol go too low, and that's not good for the body. Also, you want to take phosphatidylcholine and fish oil 3 hours after doing any cyclodextrins. Remember, alpha cyclodextrin can remove rancid phospholipids from the cell membranes, and most of us are deficient in phospholipids anyway. We go from some 90% phospholipid content when we're young to 10% as we get older in membranes. So the goal is to use cyclodextrins to flush out the old and rancid and oxidized fats and phospholipids, but right afterwards we want to give the membranes healthy fats and phospholipids to rebuild themselves. Hence, 3 hours after taking any cyclodextrins, some phosphatidylcholine and some good quality fish oils. My own personal experience. So I have a genetic flaw that my body tends to accumulate fat deposits. And so I've got a little bit of plaque in the arteries. And after 33 days of taking cyclodextrin, I took an ultrasound image before and then after. The plaque, the largest piece of plaque in my carotid artery is down 5%. Now, you might think that that's not a lot, but in the world of plaque and arterial health, a 5% drop in a month is extremely significant. A couple of notes. Cyclodextrins do cross the blood-brain barrier, but they do it slowly, so it's much better to be using cyclodextrins preventatively, or at the very first sign that maybe something neurologic is taking place, rather than waiting for that condition to get more advanced, because again, it can get past the blood-brain barrier, but it takes a bit of time. Each tablespoon of the albodextrin contains a sextillion of the alpha and a sextillion of the beta cyclodextrin molecules. That's a 1 with 21 zeros, or 1,000 times a million times a million times a million. So even though a tablespoon or two may not seem like a lot, there are an awful lot of sugar donuts in there to do their work. What kind of sugar are cyclodextrins made out of? They're made out of glucose, but don't worry, it's not the kind of glucose that's going to raise your blood sugar, because it's not metabolized by the body. The cyclodextrins that go into the bloodstream leave out the urine. The only difference is hopefully they're bound with some things that you want to have removed from the body. The cyclodextrins that aren't absorbed into the bloodstream pass through the digestive tract, where they become prebiotics, feeding and raising the number of Bacteroides, bifidus, and lactobacillus bacteria, as well as absorbing intestinal LPS, the inflammatory compound made by bad bacteria in the gut. Cyclodextrins are on the GRA list. They're generally recognized as safe. They're added to lots of foods that we eat just in small amounts, and you actually find them in tiny amounts in corn and in beer. They're made by mixing starch with some enzymes. Cyclodextrins in proper amounts are incredibly safe, incredibly useful, and if that's something that you want to try adding to your protocols, here's the product that we make. Take care.